That one.
Yes.
Got it. I can control them.
Okay.
All right. Should I start? Before I get started, yes, I'm with the Space Weather Prediction Center. I started out my career studying the Northern Lights, the aurora, and have studied space weather and its impact on the terrestrial environment for most of my career. One of the things I would comment about the discussion that just went on about some of the, shall we call them skeptics, of the impact of humans on climate, I often give a talk like this and I say that if I could honestly say that the sun caused all of the warming, my career would be made. I could get funding, I could do anything I wanted, because so many people would love to hear that answer, but we can't honestly say that, and I hope that that comes through in my presentation here. The other thing I will comment on, though, is that it's a two-way street. There are people out there in the climate community who have also, basically because of those who say the sun can cause all the climate change, have said that the sun causes no climate change at all. And so there are extremes in all cases, and I hope that we can provide some sanity here. So I'm going to talk about climate and climate changes that were going on now, and try and put them in perspective of the last 400,000 years, and then maybe talk.
I'll break in if I think there's a question that you need to address.
Absolutely, please do, because I'm fine with interruptions, and I'm glad to answer questions at any time. This image here shows three of the main climate drivers that I'll talk about: solar variability, volcanoes, and then the fossil fuels or anthropogenic effects. So I will try and bring all of those into the picture. But this is what we're looking at and what we're talking about, which is the climate change associated with that has occurred over the last 130 years or so. This is the period during which we have good temperature records because we have thermometers and we don't rely on proxies for climate like ice cores and isotopes and things like that. So this is a pretty accurate picture of the climate. Now, of course, there are those who say that this is not real and that there are other explanations for this, but I think pretty much now people believe that this is in fact the climate record. And I'll point out that over the last 130 years, the temperature change on a global average is sort of the 6/10 or 8/10 of a degree Celsius. So other evidence, of course, of these anecdotal or individual elements like glaciers, which have melted dramatically, ice caps, which are continuing to melt. I think this year broke new records. And so these are obviously evidence of change of climate on a very, very large scale. But how does this fit into the climate of the past? And so now I'm going to go back in steps, back 100,000 years, or back to 400,000 years, and we'll start with the last 1,000 years. So based on temperature records from tree rings, corals, and ice cores, the climate change we're seeing now in the red on the far right of this picture as compared to the climate of the last 1,000 years. And you can see that the climate was relatively stable, and then there has been a dramatic warming. The one thing I would point out, though, is that the blue and black line represent the climate, but they represent some sort of average, and the gray shaded region behind it represents sort of the outliers, so that there may be records, depending on which records you look at, that show a climate that was either significantly warmer or even significantly cooler than that blue and black line. So there is quite a bit of uncertainty as you go back in time as to exactly what the globally average temperatures were. Now we can go back 10,000 years, and you see that most of the period, the climate was relatively stable, similar to what we have now. But then, of course, about 10,000 years ago, there was a very, very precipitous change in the climate. It was a warming from quite a bit colder to the current temperature. It was about a 4-degree Celsius globally averaged warming that occurred over the course of about, say, 2,000 years. And just for comparison, we were looking at a warming of 0.2 of a degree over 100 years. So that's like 2 degrees over 1,000 years. So it's not unlike the change that we are seeing today in terms of the number of degrees per year that you would anticipate. And yet when you look at this record, it's a rather sharp change. So then we can go back even further. And now each time you can see I've taken and sort of reproduced in a thumbnail the previous slide on the right, and then add yet another. This time we're going back 150,000 years, and yet now you start to see this very, very long cold period where the temperatures were much colder than they are today. Then 100,000 years ago there was this interglacial warm period where the temperatures were more similar to today. So if you look at this record, what you could conclude is that the temperatures are usually colder than they are today, and that there are these brief periods of a few 10,000 years where the temperatures are as warm as we are now. Now, one of the things that I've had some discussions of recently, this 8 degrees colder for 100,000 years, this 8 degrees was actually the temperature recorded at the Arctic Vostok ice core. The globally average temperature was presumably quite a bit, the difference was quite a